네, 안녕하세요. 저는 바이텍캠스의 정진이라고 합니다. 오늘 뭐 바쁘신 와중에도 이렇게 많이들 참석을 해주셔서 정말 감사하고요. 오늘 D360 프로그램에 대한 웨비나를 진행하도록 하겠습니다. 그 웨비나 들으시면서 혹시 질문 사항이 있으시면 그 질문창에다가 그때그때 말씀을 해주시면 될 것 같습니다. 나중에 저희가 Q&A 시간에 이런 부분들은 질문에 답변 드리고 그렇게 진행을 하도록 하겠습니다. 자, 그래서 오늘은 신약 개발에 속도를 더해줄 인포매틱스 플랫폼 D360이라는 제목으로 말씀을 드릴 예정입니다. 뭐 아시겠지만 신약 개발 과정에는 굉장히 많은 시간과 돈이 투자가 되고 있습니다. 그래서 뭐 시간이 곧 돈이다라고 해도 과언이 아닐 것 같습니다. 아마 이 연구를 하시면서 프로그램을 이제 전혀 사용하지 않는 그런 곳은 없을 거라고 저는 생각이 됩니다. 그만큼 이제 뭐 아주 많은 연구 데이터들이 공개가 되어 있고 또 이런 데이터들을 굉장히 쉽게 얻을 수가 있기 때문에 그만큼 최근에는 또 신약 개발을 좀 더 효율적으로 하기 위한 수많은 방법들 또 이를 지원하기 위한 많은 프로그램들이 개발되고 있다고 보고 있습니다. D360은 특히 이런 신약 개발 과정에서 생성되는 수많은 복잡한 데이터들에 손쉽게 접속하여 분석하고 이를 통해 좀 더 빠르고 질 높은 결정을 할 수 있도록 도와주는 프로그램이라고 할 수 있을 것 같습니다. 저희 바이텍캠스는 1991년부터 캠 인포매틱스 및 바이오 인포매틱스 분야에서 전 세계 유수 기업들이 사용하고 있는 최고의 솔루션들을 선정해서 국내에 소개를 해오고 있습니다. 특히 21년에는 저희가 세타라사와 국내 디스트리뷰터 계약을 체결을 하고 세타라사의 제품들을 국내에 소개를 하고 있습니다. 세타라사 같은 경우는 현재 전 세계 11개 규제기관과 그리고 1600개 이상의 글로벌 제약회사들을 고객으로 하고 있고요. 바이오 시뮬레이션 소프트웨어 및 기술 지원들을 통해서 고객 중 90% 이상이 굉장히 성공적으로 신약 승인을 받도록 한 사례들을 충분히 가지고 있습니다. 그 중에 이제 저희가 오늘 소개드릴 D360 프로그램 같은 경우에는 다양한 소스의 데이터들을 통합 분석할 수 있는 그런 소프트웨어라고 한마디로 말씀드릴 수 있을 것 같습니다. 이제 그 신약 개발을 하기 위해서는 굉장히 다양한 데이터들을 통합적으로 이해할 필요가 있다고 생각이 됩니다. 그래서 이런 데이터들 중 가장 관련성이 높은 데이터들을 효율적으로 찾아낼 수 있는 능력이 또 필요할 거라고 생각이 되고요. D360은 이런 다양한 데이터 소스들에 접속해서 데이터를 분석하고 디자인할 수 있는 기능들을 제공을 하고 있습니다. 현재는 전 세계에 6,000명 이상의 사용자가 있고요. 그 다음에 글로벌 탑5 제약사들에서 사용 중에 있습니다. D360의 이제 특징들을 좀 말씀드리려고 하는데요. 이 D360 프로그램은 스몰 몰레큘뿐만 아니라 올리고 뉴클레오타이드나 펩타이드, 뭐 항체와 같은 다양한 데이터들을 이제 분석을 할 수 있고 디자인할 수 있도록 도와주는 프로그램이라고 말씀드릴 수 있을 것 같습니다. 그래서 후보 물질들을 이제 만들고 또 시험하고 최적화해서 분석하는 이런 일련의 사이클들을 더 빠르고 효율적으로 진행할 수 있도록 도와줄 수 있을 것 같습니다. 또 이 D360 프로그램은 굉장히 유저 프렌들리한 기능들을 제공을 하고 있는데요. 드래그 앤 드롭만으로 쉽게 이제 쿼리들을 구축을 해서 데이터를 필터링하고 또 검색할 수 있는 그런 기능들을 제공을 하고 있고요. 그 다음에 여러 가지 이제 데이터들을 디자인하고 분석하는 데 필요한 다양한 시각화 기능들도 제공을 하고 있습니다. 그리고 이 신약 개발에 필요한 몇 가지 파라미터들도 이제 계산할 수 있는 기능을 제공을 하고 있고요. 그리고 결정적으로 이제 뭐 사일로화를 좀 막기 위해서 이 결과들을 분석한 내용들 이런 것들을 이제 팀원이나 외부 다른 파트너들과 공유할 수 있도록 협업 기능도 지원을 하고 있습니다. 이 그림은 이제 일반적으로 신약 연구 과정을 표현을 하고 있습니다. 화학자가 이제 후보 물질들을 만들어내면 이 물질들의 구조 정보 및 화학적 특성 등을 저장하는 화학 정보 저장소가 아마 있을 거고요. 그리고 만들어진 물질은 바이올로지스트들에 의해서 이제 어세이 실험을 하고 이런 데이터들은 어세이 데이터로 저장이 될 겁니다. 그런데 이제 저희가 최종 결정을 하기 위해서는 이런 데이터들을 전부 통합해서 평가를 할 필요가 있겠죠. 그래서 이 D360은 이런 모든 소스들에서 데이터를 가져와서 통합하고 분석할 수 있는 그런 기능들을 제공을 하고 있습니다. 그래서 오늘 웨비나에서는 이 D360 프로그램 시연 영상을 통해서 이 프로그램의 기능들, 장점들 이런 것들을 좀 설명을 드릴 예정입니다. 그래서 제가 그 전에 간략히 이제 프로그램에 대해서 설명을 드리고 있는데요. 지금 보고 계신 화면은 D360 프로그램의 대시보드라고 하는 화면입니다. 앞에서도 이제 말씀드렸지만 굉장히 쉽게 이 쿼리들을 생성을 해서 사용자가 원하는 데이터들을 검색을 해낼 수 있고 필터링할 수 있다고 이제 말씀을 드렸는데 이 대시보드에서 보시면 이제 사용자의 프로젝트나 어떤 기관의 요구사항에 맞게 이제 쿼리를 구축을 하고 이런 화면들을 사용자에 맞게 구성을 할 수 있습니다. 또 이 대시보드는 저장도 가능하고요. 또 편집이 가능하기 때문에 추후에도 이렇게 설정된 대시보드를 통해서 같은 결과들을 계속해서 얻어보실 수 있습니다. 그리고 이 D360 프로그램은 이 데이터 검색을 위해서 유니서치와 폼서치라고 하는 두 가지 검색 폼을 제공을 하고 있습니다. 자, 먼저 보시는 화면은 이 유니서치 인터페이스이고요. 이 유니서치는 좌측에 보이시는 그 쿼리들, 질문 사항들, 기준들을 드래그 앤 드랍으로 리스트화 시킨 다음에 사용자가 원하는 검색 조건들을 설정을 해주고 여기에서 이 조건들에 만족하는 결과들을 이제 검색할 수 있는 그런 기능입니다. 그 다음에 지금 보시는 그림은 이제 폼서치 화면인데요. 이 폼서치는 말 그대로 이제 사용자가 원하는 폼을 구성을 해서 여기에 검색 조건들을 입력을 하고 결과도 이제 폼 내에서 확인을 할 수 있는 기능을 제공하고 있습니다. 아마 예전에 이제 그 캠파인더 같은 것들 사용해 보셨으면 아마 이 화면이 조금 익숙해 보이실 수도 있을 것 같아요. 그래서 그런 것처럼 이제 폼을 사용자가 마음대로 이제 구성을 하고 여기서 결과를 확인하는 그런 기능들을 갖추고 있습니다. 자, 그래서 이제 사용자가 구성한 이 폼을 통해서 폼 뷰로 결과를 확인을 할 수도 있고요. 또 옆에 보시면 이제 우리에게 아주 익숙한 화면이죠. 엑셀에서도 많이 보실 수 있는데 이 스프레드시트 형태로도 결과를 확인하실 수 있습니다. 또 한 가지 중요한 기능은 뭐냐면 데이터 머지 기능입니다. 이렇게 이제 기존에 불러들여온 데이터에다가 추가로 그 데이터를 넣어야 할 경우에는 이 머지 기능을 통해서 데이터들을 추가하고 또 이걸 가지고 분석을 해볼 수 있는 그런 기능을 제공을 하고 있습니다. 자, 그리고 앞에서도 이제 계속 강조해서 말씀드렸는데 이 굉장히 다양한 시각화 기능들을 가지고 있습니다. 그래서 보시는 것처럼 결과도 이렇게 다양한 뷰어 형태로 확인을 하실 수가 있고요. 그 다음에 다양한 그래프 혹은 차트 기능들을 이용을 해서 데이터들을 분석하는데 사용을 하실 수가 있습니다. 자, 그다음에 특별히 이제 뭐 클러스터링이라든지 R그룹 분석 또 컴비캠을 통해서 가상 물질을 생성한다든지 하는 그런 기능 등을 제공을 하고 있기 때문에 아마 알고 계신 거의 모든 형태의 화합물 데이터 분석은 이 D360을 통해서 가능하실 것으로 생각이 됩니다. 일단 제가 간략하게 이 D360에 대해서 좀 설명들을 드렸고요. 지금부터는 이제 시연 영상을 보시면서 앞서 말씀드린 기능들을 확인해 보실 수 있는 시간을 갖도록 하겠습니다. 앞에서도 이제 말씀드렸지만 혹시 질문이 있으시면 그 질문창에다가 질문을 해주시면 되고요. 시연 영상 시청하신 후에 Q&A 시간에 저희가 답변을 드릴 수 있도록 하겠습니다. 자, 그럼 그 시연 영상 시작하겠습니다. 이 영상 플레이 하는 데까지 대략 3초 정도 걸리는데요. 잠깐만 기다려 주시면 감사하겠습니다.
So welcome to D360. We wanted to give you a brief overview of what D360 does and how it works. D360 has 3 major capabilities to provide you access to your data, to help you analyze and understand that data, and also share your findings with colleagues. What you can see here is my D360 dashboard. The D360 dashboard can be customized how you like. On my dashboard, I have a number of what we call quick search widgets. These are the white rectangles. Each of these is a query or a data view that either myself have built or has been shared to me through a shared workspace. This one, for example, is for the kinase project. But the most important part of D360 in daily use is quick access to data. So if I want to get my CSARC project data, I just find the appropriate widget here and click search. Once I've done that, D360 now is going and searching all the data sources to which it's connected to and bringing back this project view of data. In this case, each of our rows in the data set is an individual chemical compound associated with this particular project. We've got the identifiers, we've got chemical structures, which we'll use later to delve into more detailed analysis of structure. Then we have assay data columns. These assay data columns are all aggregated, so we're calculating a geometric mean of this data. And also there are little in-cell indicators to describe both the quantity of data behind these numbers and also the quality. Here, this first column, the CSARC column, is my primary activity, and low potent values have been colored green to draw attention to them. To understand the quality of the primary activity even further, we have rendered dose response curves, and you'll see that there are overlaid dose response curves where multiple tests have been conducted. And this gives me an idea of how good the fit to the data is and whether there are any outliers in terms of the determination. We have a number of additional columns over on this side, which are all selectivity assays. So I do not want potency in these assays. I need high values. So here we can see this compound is very active at 0.12 nanomolar, but we also have selectivity problems because it's active in other particular assays. So this has given me an idea and an overview of my whole project data, and we're sorted currently by our CSARC activity to give the most potent compound at the top. One thing to note here is if I scroll through the data set, D360 will handle nicely values such as greater thans or less thans directly within the same columns, so there's no need to deal with multiple columns, and this data will be treated numerically as far as analysis and plotting and visualization is concerned. If I scroll right down to the bottom, you'll also see that sometimes biological results are textual in nature, and we can handle again all this kind of data in the same column, and so you don't need to be concerned about missing this information and not realizing that this compound was tested but no good result was created. So let's just scroll back up to the top again. So now we can see all our color-coded columns. We've got a couple of pre-calculated properties that come from the data source. And while these are useful for my project, I want to examine some additional molecular properties. We can do that very quickly just by going to data and saying, add calculated properties. We get an interface now that allows us to add some of the calculated properties that are provided directly with D360. So if we want heavy atom count and polar surface area based on the chemical structure, we can easily add that. But many times we'll also integrate with calculated properties that customers have available. And at our largest customer, there are many hundreds and maybe even thousands of calculated properties to do with properties of the molecule or predictions of activity or anything else that you can imagine. So let's just calculate those properties. And so now at the end, we'll have some additional calculated property columns. Let's just move those together with our other ones. And our TPSA is a little narrow to show the data, so we'll expand it. Now, all of this numeric data can be formatted appropriately. So it's right now at 2 decimal or 3 decimal places of precision. If I wanted to, I'd change that to 2 significant figures. Next, we have what we call an equation column. This one is just calculating a quick selectivity ratio between our primary activity and our EGFR. If I wanted to change this equation, we can quickly just double click and we can see this is the equation, but we can apply any of the fields in our data set with a whole variety of different equation functions, including doing logical operations, mathematical operations, and including some scientific calculations like ligand efficiency. I'm not going to add any more of those right now. Instead, we'll just take a look at what else we've got here. So this data set has been divided up by a certain kind of substituent. So this is a chemical series column, which just gives the assigns the compounds to a chemical series based on the presence of a substructure. If I go and edit this, we can take a look at what that is. So we could just see very briefly, we've got para-amino series, a para-halo series, where we've used an atom list. So won't edit those, we'll just take a look. Next, we've got what we call an annotation column. And this annotation column is where we can start assigning priorities which can be communicated to other users. So this is user-added data, but this user-added data becomes queryable and can support a whole range of different workflows. Probably one of the most important columns here is our Mpo score. So what we're looking for in our data set, if we scroll back to the beginning, is we want potency in our CSRC activity, but we don't want it in our other assays. So we can see just by the presence of red here that even though this is the most potent compound, it's not got the best profile. If we look at our Mpo score just for a second, we'll just go and edit the Mpo score. We can see that for our CSRC activity, we want low values, and for all of the other assays, we want high values, and that gives us a good profile. There's more detail underneath this to say, well, what do you mean high values and low values? We're not going to look at that right now. We'll just say, all right, we'll take the score as is. So what I'm going to do now is just sort by our Mpo score to find out those compounds with the best profile. So just select sort, and we'll sort in descending order. And now our topmost compound we can see has a 90.5% match to our profile. Although it's not as active in our primary assay, about 10-fold, 20-fold less active, we see that it's got a good profile across all of these others. And so if in my prioritization, what I'm going to do is just say that this has a high priority because this is an important compound. Once I've made that change, then that data is actually available to anybody else in their queries. But this view of data is a fairly simple view of just a spreadsheet. I'm interested in creating a richer view of information. So first of all, what I want to do is understand a bit more about this Mpo score. So what I'm going to do is just create a quick bullseye plot. And we're going to create this bullseye plot based on Mpo score. And when I create this, it'll create a circular target type presentation where our ideal score is at the center. So this is, if we've got a compound there, we have something that matches our ideal profile and is good for our project. The further away a compound is the further away it is for that score. But compounds with different profiles are separated radially. We can see that very quickly if we turn on the spreadsheet to details mode, which means it's going to show only those compounds selected in our bullseye view, and then select a group of compounds over here, which are about 70% similar to our profile. We can quickly see that they have a pretty good profile in terms of their cell activity. We see a lot of green over here, but they don't have particularly good primary activity. If I look at the other side of the plot, however, we can start seeing that there are compounds that have a good primary activity, but we have more problems in our HCK. And we can color this plot further, either by our Mpo score or perhaps by the date of registration of these compounds to see how we're progressing. In this case, I'm just going to quickly color it by using the legend here and say color by value, use our Mpo score, and it picks up the same color scheme as we had before. So now we've made our data set a little bit richer and a little bit more interesting. I'll just turn that details mode off for the spreadsheet. Let's have a look at what else we might want to look at. What are the problems we might have in this? Well, we want to optimize a number of properties simultaneously, which is why our Mpo score is so useful. But we also want to perhaps understand whether there are correlations in the assay results. We can do that very easily. We can just go to the analysis menu and request a correlation matrix. And I'm just going to say, look for correlations between our assay data. So we'll just select that, say add, and then we'll compute a correlation matrix. There are actually 3 different tabs here. This one looks at linear correlations. The second one looks at linear log. And the most important thing here is the log-log correlation. So now we can understand whether there are any liabilities in what we're looking at. So we can see here that we've got our CSRC, our primary assay, but it has strong correlations with column 4 and column 5, which are our c-able and HCK. So let's select those particular entries and we'll create scatter plots for those. And we'll just nicely rearrange our windows so we can see this data a little better. And then shrink down our spreadsheet, grow our spreadsheet a bit. So now we're starting to get a better, more close understanding of what's going on. So we've got a good view of our Mpo and how things match up, but we can also see there are strong correlations between our primary activity and our c-able. I might want to think a bit further about this and add some filters to the data set. So here, for example, we can just go and say, let's add a filter on our Mpo score, because that's a very important thing for us. And let's also add a filter on our primary activity. And I'm just doing this simply by right-clicking the columns. So one of the things about D360 is we do spend a lot of time with our customers and users in order to develop the functionality in a highly usable and simple manner. Now we've got these filters. This filter is best presented on a log scale. So let's just pop that on a log scale. Now we can quickly filter and say, well, we're not interested on the really low scoring compounds, nor are we interested on those compounds that have poor primary activity. And now we can see that we filtered down to a subset of compounds, and particularly we're looking for those which are off target. But in terms of what I've done so far, I'm kind of happy with this view as an improved view of this project information. So before I go further, I'm going to save this and make it available to the team. The way I'm going to do this is I could save this data set, which presents the information as is, but what I'd rather do is save a query that generates this data view. So what I'll do here is I'll just go to my file menu. I'm going to say save as. When this comes up, I'm going to make sure it's in the shared workspace so that my colleagues can access this data view. I'm going to save it as a query, and I'm just going to give it a new name. And lastly, you'll notice that we've got save as widget checked, which means it's going to show up on the dashboard. So once we've done that, we can click save. I don't need this data set anymore, but just to show you what has occurred there on this dashboard now, you'll see that I have a new CSRC project widget. I can customize this how I like. Now this is different from what we started with because it does the additional pieces we requested. So if I actually run search on this, you'll see how that operates. So now we see our data set just as we did before, but as it completes and all the macros execute, you'll see that we've got our filters in place, we've got our MPO map, that we've got our correlations that we are considering here. And we could refine this view further so that it makes more sense to the project team. So having said that, we started here from a query that had already been built. So let's move on now and have a look at how these queries are built in the first place. So next we're going to say, well, how was that query built in the first place? A really important facet of D360 is it allows users self-service access to data. So any user can go into the system and build a query without requiring any specialist IT support or any knowledge of databases. And this is one of the aspects of D360 that means it's one of the lowest maintenance applications you can possibly get. It requires extremely little effort to maintain. So let's close our dataset window. We'll get back to our dashboard. Now, what I'm going to do now is build a query that leads to a spreadsheet. D360 supports a lot of data visualizations, including forms. So you can choose between spreadsheet or forms or have both. Today, we'll build a quick query that leads to a spreadsheet output. So on the top left, I'm just going to say, build a new query. Now, D360 at its heart is a very general scientific informatics application. Most users currently work in the small molecule domain, and therefore they tend to want data sets where rows are chemical compounds. But you can see here, what we're going to do is pick what we call the query data category. So we can pick compounds, small molecules. We could also pick batches if you wanted each row of your data set to be a batch. But we could also work across different modalities. So for example, biologics, we could pick up biotherapeutics, or more reasonably, you'd have a list of things like oligonucleotides, peptides, antibodies, and all the entities around that, whatever you need for your research. And we even have examples of preclinical data integrated with D360. So we can handle a wide variety of information. But let's return to small molecules. So I want a data set that's related to compounds. So we'll just pick small molecules here. Now we're in the query interface. At the top left, it tells us what our data category is. Below that is all of the data that D360 is able and configured to access. This is what we call the data catalog. Essentially, think about it as the supermarket of data. So if I look in the small molecules folder, I see Chemical ID, and we can add that over. I also want to see structure, and we can add that over. And now you can see that in this top right area, we're now building a different query. So here there's a calculated properties folder. I'm just going to say I want all of them. It's going to give me every single calculated property that's available from the database. And so we very quickly and easily built our initial query. And all we had to do is pick what we were looking for. Now, the data catalog itself is laid out generally differently from customer to customer and is entirely designed so that users can quickly find the data they're looking for. So very importantly, we want to find assay data. So in this system, we actually have our assays divided up by projects. So if I look in the in vitro results by project, I will see all the projects, and the project I'm interested in is the CSRC kinase. So we can go in there and we can see all of the projects associated with that. So I know that I want the CSRC assay, so I'm just going to drag and drop that into my query. So once I've done that, it gives me a band, but this band is for the whole assay. So all I'm going to do is say, well, which of these results do I want? In this case, I want the IC50. If this assay had been run under different conditions, we would see those over here. This one hasn't. And if I wanted other information about the run of the assay, I'll click the Analysis Information tab, and I can bring out any other information about the assay or about individual runs. On the results, we can also see that the IC50 is aggregated with a geometric mean. And if I want to change that or aggregate differently, I can just click the mean, and we've got a whole variety of different aggregation functions that we might be interested in. So for example, if we were looking at antibacterial, we might want the most recent results because we may have genetic drift in our bacteria. If it was something like a percent inhibition, we would have an arithmetic mean. We would always want to set this up so that a user didn't have to change it. So we now have our primary assay result here. Other methods of finding our assays, we could just filter by the name of the assay. So if we're looking for a CSARC assay, we can just type CSARC and we can see everything that matched CSARC. And here, for example, is our project folder. Here are other CSARC folders. We could add things that way. Let me just remove that filter. And the final way of either after browsing or searching is we can actually use compound identifiers to find the data we're looking for. So if I click on this button, and I could either type in, or in this case, I will just paste in one or more compound IDs and click OK. That then gives us a list of all the assays that that compound was tested in. So here I could just go in and select those assays which are of interest in this particular event. So those are the assays I want, and I'm just going to drag those again into my query. Because I'm adding many assays, it just says, hey, here's the results those assays have. Which ones do you want? So I'll just say, I want the IC50s. So now we've added all of our assay data into the query. The last thing we need to do is say, well, which compounds are we looking for? Well, I can do this in a variety of ways, but the key way is to constrain the assays. So for example, I can go to my CSARC assay and I can set a specific criteria on the IC50 to say it must be less than a certain value. But most commonly users will just say, I want everything tested. And we can actually do that for all of these assays. So we can select all of the assays and say for each of them, we want everything tested. So any compound tested in any of the project assays will now be retrieved. The last thing I'm going to do is change how these constraints work with each other. So right now, I've said it must be tested in all of these assays, but that's not what I want. What I actually want is anything tested in any of these assays. And I can change that very easily by just saying, don't match all the constraints, match any. And I can also, if desired for specific purposes, add custom logic. So now our query is complete. All can be done in a few minutes. None of it requires any information about databases. None of it requires IT support. Now we've done that, we can just go down here and click search. And now we're going to get our data back. So each row, again, is going to be a chemical compound because that's what we chose as our data category. And then our columns are each going to be individual assay results and our calculated properties. So here we have a whole variety of different data. Now, before I want to make this available to anybody else, I'm going to clean this data set up a bit. So first of all, we're just going to take all of our assay data and reformat that. I'm just going to change that formatting into 2 significant figures. I'm going to go back and rename these assay columns. So we'll just see rename, and we're actually going to rename multiple data fields. So I'm going to take this section and say find that and just replace it with nothing. And then I'm also going to take this end section and do the same with that. And that way we can very quickly get rid of all of that stuff. I also notice I got an extra field I don't need, so I'll just hide that. The next piece we can do is just color this data. So I'll just use the quick color feature and do a traffic light. Low values are green, high values are yellow through red. And we can apply that all to our other assay columns, but we'll do the other way with a reverse traffic light. So now we've already quickly got a query that brings our data and formats it. We certainly could do a lot of other things here, but let's just make this available to the team just by going to File, say Save As. Make sure we've got our team workspace selected, saved as a query. We'll call it team query, and we'll just say save as widget. Click save, and if there's a current version, we'll overwrite that. I can do that because it's my query. And then when we go to the dashboard by closing the data set, we see we have team query. And if I executed that query, then we'd get to the data set that we just saw, but with any new data. And now all of my team members who are subscribed to this Kinase workspace, they can all see that data as well. So we've seen everyday use in terms of using widgets to get to data very quickly in one click. We've seen how straightforward it is to build or in fact edit those queries. Let's take a look at a bit more at analysis here. So here, let's run our project data view that we ran earlier and adapted. So we have a couple of additional visualizers here, but that was just a starting point to tell us, what is of interest. And what I really want to do here is start understanding what structure, how structures are related. So I'm just going to move these visualizers to a new tab. I'm going to do that with the same, with the scatter plots, and move that to that same tab. So now those visualizers are just presented over here, and if we want to look at that, we can look at that anytime, and we'll just give that a quick name, overview. So let's have a look at how structures affect activity. So here we have our spreadsheet. What I'm going to do now is generate a structure similarity map. So we'll just click our similarity map icon, say we want to use structures, and click create. What we get here is a map where points close together represent similar compounds, and points far apart represent compounds which are different from each other. If I just disable the filters a second so we can see all the compounds, here we can see if I hover over these two structures, they are very similar to each other. They differ only by a metal. In fact, let's just select those and label them so we can see. Now let's just select them and pressing the L key. If, however, I look at compounds on the other side of the map, then label those, we can see that these two are very similar to each other. It's a para versus a meta position. These two are very similar to each other, but they're different from ones on the other side of the map. And if we then say map on a color, say our Mpo score again, then we can start to see where are our good profile compounds. So what we see is a lot of green throughout, but we can also see areas, let's just zoom in here, where we're seeing both yellow and green points, quite close together. That tells me my Mpo is a little unstable. If we toggle back out on the zoom, we can start looking for areas where we see a lot of green. So here we're seeing a lot of stability, but also what we're seeing is that these weren't measured or didn't have good quality values. So let's just enable our filters. Let's move the sliders all the way back out, but let's eliminate text values here. So we're not interested in those things which really didn't have a good value. So then we can say, all right, what's a good area of this plot? And maybe the interesting area is somewhere around here. Okay, and if we switch the spreadsheet to details viewer mode, we start getting an idea of, all right, what kind of compounds are those? And so we see things with these unsaturated rings with nitrogen containing, and some excuse me, some halophenols in the other side. So those look interesting to us. But what I really want to do here is generate some new compounds and new ideas for synthesis. And the way I'm going to do that is to understand how these molecules break up for R group analysis. So we'll just start at the top and perform an R group analysis. So I'm just going to click this icon. Here is our definition of a core. Well, we need to refine this at R groups, so I'll just double click it. Once that does, it launches the configured sketcher. So you can choose between ChemDraw, IsisDraw, BioviaDraw, or Marvin. Here, this is BioviaDraw, so I will just add on the R group labels. So we'll put an R1 here, and we'll keep it simple, just do an R2 here, and then remove the extraneous atoms. So now we have our core. Let's transfer that back. Before we actually add the R groups, we'll just do a quick structure analysis to find out whether that core is going to work for us. We can add multiple cores in here, and so therefore encourage the analysis of multiple chemotypes at the same time. Here it says 205 structures have the core, so we're okay. We're only missing out 5. You can also look at which structures got missed out. So here's an interesting example that we might want to add in, and we can also add these structures into cores in order to cover more of the data set. I'm not going to do that here. Instead, we'll just add our R groups to the spreadsheet. So if we scroll over, we'll now see all our R groups there. There's a lot of things we can do with R groups. So for example, we can calculate properties on R groups like we did on the main compound to understand how R group properties might vary and affect activity. We can actually do a free Wilson analysis to understand the R group contributions. What I'm going to do is something a little simpler. All I'm going to do is generate an R group matrix of R1 versus R2. So I'll just select those columns and click the R group matrix. Now, R group matrix takes up a lot of space, so I'm just going to move that to its own tab. Okay, and what we see here now is our R group matrix. These are all our R2s, starting from simple and small up to complex and large. Similarly, we've got R1s on this axis. This isn't very useful right now. Let's see where our good MPO, our good profile compounds are. So here we'll just color by our Mpo score from green to red and apply that. Well, there's no rhyme or reason here to the order of our R groups on the axis according to what we're looking for. So I'm just going to go to the x-axis and I'm going to sort the axis in descending order by MPO. And if I can't find that, I'll just type it in and we'll just apply that change. And we'll do the same with the y-axis. So we'll do by MPO. Okay, so what we've done there is moved all the R1s that are found in good profile compounds towards the origin. And we've done the same with the R2s. So all the combinations down in this quadrant should yield compounds with good profiles. We can take a look at this quickly by just choosing those R groups close to the axis and saying we want to enumerate what's in this corner because we haven't made or tested those compounds yet. So we'll just say enumerate. We'll see there that it's automatically picked the core that we have for us, and it's picked 5 R1s from our graph and 5 R2s. If we wanted to, we could apply some product filters so that when we enumerate these compounds, we don't get anything which we don't want based on properties. But I'll just click create the structures. Just says, hey, this is what we're looking at. These are the structures that we're going to create. If there were any duplicates with compounds in the data set, those will be eliminated. But let's just click Add Selected to Dataset. If we now jump back to our spreadsheet, we'll see that we've created a whole lot of virtual compounds. I'm just going to close our similarity map because we're not so interested in that anymore. So here we have a whole load of new compounds which we expect we should be able to synthesize fairly readily because we've made other things with the same R groups. Now I want to keep these and share them with my colleagues. So what I'm going to do here is just select these compounds because these look good. And what we will do here is capture these compounds as design compounds. So we'll just say capture them. We'll just say capture all the selected virtual compounds and we will associate them with this project. Once we've done that, we'll click capture. Now those compounds are all being stored in a separate database. They are given new and unique IDs, but they're also treated as project compounds. So if we now close this, we've taken this data set and we've done a lot more detailed analysis in order to come out with those virtual compounds, which are now design compounds. So let's just capture this because I want to use this as a new query for myself to understand what's going on the next time when there's new data. So now we've just created all of these design compounds. So I want to capture this whole query to be my view. So not necessarily share it with the team, but just for me because I've done all of these extra pieces to analyze the information here. So again, I'm just going to save this. But this time I'm going to save it to my personal workspace. I'm going to give it a new and imaginative name. And I'll save it as a widget. So that's all good. Let's close that out. Now, if I come in tomorrow and want to do further analysis, I have my more detailed analysis here. And if I run that, what you'll see is it'll go off. It'll get any new data available. And it will bring back all that new information to show me. It will also bring back all the design compounds that were part of what I did earlier. So not only has it brought me back all the real compounds that we're working with, but also the design compounds. And those design compounds I can also prioritize. So the point of this demonstration really was not to try and show you everything about D360, but to show you how you can get to your data in a single click, how you can format that data how you want it, how you can share that information with your colleagues, and also to show you some of the scientific tools that we've built in, the handling of modifiers and text values, the display of quantity and quality of assay results, the ability to show dose response curves for deeper understanding of the data, the ability to look at multi-parameter scores because you're looking for a profile and not a single value, and then the ability to add graphs and charts and some of the chemistry capabilities that are inherent within D360. So thank you for your attention. We'll stop there. Certainly, if you'd like to know any more, we'd be happy to talk.
네, 시연 영상 잘 보셨는지 모르겠습니다. 저는 볼 때마다 굉장히 흥미로운 것 같아요. 아마 제가 앞에서 이제 말씀드린 것들하고 좀 종합을 해보시면 좀 더 이해하기가 쉬우실 것 같습니다. 그리고 관련해서 혹시 질문이나 트라이얼 같은 것들도 가능하니까요. 저한테 한번 요청을 주시고요. 일단 앞에서 질문해 주신 내용들 먼저 답변을 좀 드리겠습니다. 이제 첫 번째 질문 주신 게 이제 PC에서 인스톨하는 버전만 있냐라고 이제 질문을 주셨는데, 이 프로그램은 PC에 인스톨하는 프로그램이고요. 인스톨하신 다음에 이제 사용을 하실 때 그 서버에 먼저 접속을 하셔서 아이디 패스워드를 입력을 하시고 인증을 받은 다음에 이제 프로그램이 실행되는 방식입니다. 그래서 설치하신 다음에 사용하실 때는 이제 온라인이 필요할 것 같습니다. 그 다음에 이제 두 번째 질문은 한국에 고객이 얼마나 있냐라고 질문을 이제 해주셨는데, 아마 제일 많이들 궁금해하시는 사항일 것 같아요. 근데 이게 지금 국내 출시된 지가 얼마 안 됐습니다. 올해 저희가 이제 3월경부터 저희가 2월부터 이제 그 정도부터 시작을 했는데 아직은 국내 고객은 없고요. 지금 검토하고 계신 데들은 몇 군데가 있습니다. 이미 몇 개월 되지 않았는데 검토하시고 있는 곳들이 꽤 많이 있고요. 그 다음에 저희가 항상 가까이 있는 이제 중국이나 일본들 많이 비교를 하잖아요. 그래서 일본하고 중국에는 현재 고객들이 굉장히 많이 있는 상황입니다. 그리고 이제 가끔 이제 많이 해주시는 질문 중에 하나가 이 클라우딩 시스템하고 연동이 가능한지 이런 것들 많이 여쭤보시는데, D360 프로그램은 클라우딩뿐만 아니라 가지고 계신 이제 내부 오라클이라든지 여러 가지 서버들 이런 것들에 다 이제 접속이 가능하고요. 특히 요즘은 이제 전자연구노트 같은 경우도 클라우딩 방식들을 많이 또 사용하고 계시잖아요. 그런 경우에 이제 그런 데이터베이스들하고 얼마든지 연동이 가능합니다. 그리고 이제 많이 또 궁금해하시는 부분들이 보안 부분들 많이 궁금해하시는데, 사실 이제 연구 데이터들을 이제 저장하고 이렇게 공유를 하고 이런 작업들을 하다 보니까 이런 보안들이 굉장히 중요한데, 이 D360 프로그램은 관리자가 각각의 사용자들한테 이런 접근 권한들을 다 부여할 수 있습니다. 부여하고 혹은 제한을 하고 이런 것들이 가능하기 때문에 보안적인 부분에서도 굉장히 강력한 기능을 가지고 있다고 보시면 될 것 같습니다. 그리고 또 한 가지 질문이 데이터베이스를 새로 구축하는 것부터 시작인가요? 원래 DB를 지금 이제 데이터베이스 관련해서 이제 질문을 해주셨는데, 기존에 가지고 계신 데이터베이스하고 연결도 가능하고요. 어쨌든 이 D360 프로그램은 가지고 계신 데이터를 분석해주는 프로그램이라서 구축되어 있는 데이터셋들이 있으셔야 되고요. 이것들을 이제 불러와서 분석을 하는 방식입니다. 근데 사실 요새는 앞에서 제가 서론에서도 말씀드렸지만 이 데이터들을 구하는 게 그렇게 크게 어려운 부분이 아니기 때문에 어떤 유료로 구독할 수 있는 데이터베이스들이라든지 이런 데서부터 이제 데이터들을 얻으시고 이런 것들을 이제 분석해서 연구에 이제 접목시키는 게 가능합니다. 그러면 지금 더 질문들은 없으신 것 같고요. 혹시 추가로 더 질문하고 싶으신 부분이나 만약에 이제 프로그램을 좀 더 접해보고 싶으신 분들은 지금 여기 보이시는 연락처로 연락을 해주시면 좋을 것 같습니다. 저한테 이제 연락을 해주시고 이메일로 문의 주셔도 되고요. 그래서 한번 실제로 뵙고 또 시연도 프로그램도 보여드리고 이런 기회가 있으면 좋겠습니다. 그러면 오늘 웨비나는 여기까지 진행을 하고요. 참석해 주신 분들 굉장히 감사드립니다. 다음에 꼭 뵐 수 있기를 바라겠습니다. 감사합니다.